welcome back to a course on calculus and its applications. In this lecture, we are going to see about the algebra of functions. Okay, what do we mean by the algebra of functions? Suppose we have two functions, namely f and g. This f is defined on the domain D1 and this g is defined on the domain D2 in the sense. Okay, so if it is defined this way, we shall find the addition of these two functions, the subtraction of these two functions, the product of these two functions, the quotient of these two functions. All these can be calculated. Okay, how can we calculate these things? This is simply the function evaluated at the point x plus the function evaluated at the function g evaluated at the point x, and the similar goes for all other things. Okay, here we'll have to check what can be the domain of these algebra of functions. That is a good question, right? So because this f is defined on the domain d1 and g is defined on the domain d2, so this will be true for all x in the intersection of these two domains. Suppose, why do we take intersection? Because some points of D1 may not be in D2 and vice versa. Hence, only in the points which are common for both the functions, that is, at those points, both the functions has to be defined. Only then we may talk of these things. Okay, this is going to be true for all the cases. And here we must have one more thing. It has to be true in this domain as well as this g of x must not be equal to 0. So we will have to take into account the points where this g of x is 0. If at some point this g of x is 0, we have to remove that point from the domain of this quotient of these two functions. Okay, so let us consider some example. Let us take f of x to be under root x and g of x to be under root 1 minus x. Okay, what would be f plus g? Okay, here the first thing that we have to see is that we have to find out the domain of these two things, these two functions. Okay, here the domain is not specified, which means we are going to consider the natural domain for these two cases. Okay, the natural domain for this case would be what? We must have x to be positive, so this is going to be the domain for f of x, right? So what will be the domain for this case? In this case we must have 1 minus x to be non-negative, which tells me 1 is bigger than or equals x, therefore x must be smaller than or equals 1, which means from minus infinity till 1 it can take any value. So this is the domain of g of x, right? So now on what domain we are defining this f plus g of x? This f plus g of x is going to be simply under root x plus under root 1 minus x. This is true for all x in the intersection of these two. So here, what is d1 intersection d2? It is this thing with this thing. So if you see, you can see that it is the closed interval 0 comma 1. The points between 0 and 1 and including 0 and 1 lies in both the domains. Hence, the domain for this case would be this. Okay, so f minus g of x is going to be under root x minus under root 1 minus x for the same domain. Okay, fg of x is also under root x into under root 1 minus x, so it is going to be under root x times of 1 minus x for the same domain, right? So for the same problem, what would be the domain of f upon g of x? So what was our f? It is under root x upon under root 1 minus x. Here x can take values in what? That is the good question, right? So in this domain, okay, so these are the common points in which both f and g are defined. Okay, well and good. Now we'll have to check at some point of this interval we have a black hole scenario, that is divide by 0 or going to infinity category. Yes, when your x is 1 you will have divide by 0 category, so we have to exclude 1 from the domain. Similarly, if you define for g upon f of x, what would you get? You would get under root 1 upon x upon under root x. Here we will exclude 0, because when your x is 0 you have divide by 0 category. Now let us try and plot these functions in a graph and see whether what we have done is right or not. Okay, so here what was our f of x? Our f of x what? Under root x, right? So this is the graph of under root x, and g of x was under root 1 minus x. So now you are able to see the graphs. The green one denotes the function f and the blue one denotes the function g, right? Now we are going to plot the sum of these two graphs. Here you may very well see that this between these 2 points only it is defined, right? And let us look at f minus g as well. So it is also defined between 0 and 1. That also we are able to see here, right? And fg, this is also defined in this interval 0 comma 1. Okay, next f upon sorry, so it is f upon g. So when your x value getting nearer to 1, it is approaching to infinity, and that is why we excluded the point 1. Okay, and similarly g upon f would give you what? Here exactly the interval is same, but when your x is getting nearer to 0 it is going to infinity, right? So what we have done is verified using graphs. Now let us proceed to the next topic. So that is sorry, okay, so that next topic is composition of functions. So in this concept what we are going to do is that we will give input to a function which is the output of some other function. Suppose this is some function, we are inputting x and let this be g. Okay, so what will get? We get g of x. Okay, we give this as an input to some function and we would get f of g of x. Okay, what happens here? Here you would have something that we call it as the domain D. Okay, here you would have something which may be called as codomain or range. Let us talk about the range alone. Okay, from this range you are taking the values and giving this as an input to some other function. Okay, this one is okay, this is the domain of g and this is the range of g. Also this is going to be the domain of f. From here you are taking the values and inputting this to the function f and you are going to get some values. This one we call it as the range of f. Now if you connect this x with this f of g of x, this is what we call it as the composition of these two functions f and g. Okay, this one we write it as f of, this is what we are writing as this thing. This may also be written as g composite f. It depends on the author, right? But in general these two are assumed to be different. Okay, some prefer to write f composite g and some prefer to write g composite f. We are going to follow this notation. Here initially we have the function g and then we have f, but we write in the reverse way. Okay, that you have to remember. Suppose I give a f in the first and g in the second, we would write it as g composite f. So let us look at some examples. Okay, let us take f of x to be under root x and g of x to be 1 plus x. Okay, so what is the domain of f here? It is 0 comma infinity. Okay, what is the domain of g here? It is going to be minus infinity comma infinity. Okay, what is the range of f? It is also 0 comma infinity. Here range of g is going to be minus infinity comma infinity. Okay, now this okay, f composite g of x means, as we have seen, it is f of g of x. Okay, so what is g of x? It is 1 plus x. In the function f, in the place of x, now we will have to substitute the value of g of x. Okay, so that is going to take place and the value would be what? Under root 1 plus x. Suppose we find g composite f of x. So this will be what? G of f of x. So it is g of under root x. In the place of x, we'll have to substitute under root x in the definition of g. So it is going to be 1 plus under root x. Now you may see that these two are different. Now let us try and find the domain of these two functions. Okay, so now we are to find the domain of f composite g. Okay, so domain of f composite g, which means what? We must have this to be a real value, which means this 1 plus x has to be a non-negative quantity. If this is so, my x has to be bigger than or equals minus 1. X has to be bigger than or equals minus 1, which means x can take any value in this interval. This is what it means, right? Okay. Now, what is the domain of G composite f? Here, this 1 plus under root x has to be a positive value, right? So, this is always a positive value that we know for sure. Under root x is always a positive quantity, and when you add 1 to it, you are going to get it. So, we'll have to check the quantity for this alone. So, this means what? X takes any value in this interval. Let me repeat this once again. Uh, we must have 1 plus under root x to be a positive quantity, non-negative quantity, sorry, non-negative quantity. But we know for sure that this under root x is a non-negative quantity. That the value of under root x will always lie between 0 to infinity. When you add 1 to it, you are going to get a positive quantity, right? You are going to get some real quantity. Okay, so why do we take off there is no need of taking this to be like this. We must have this as a real quantity, and this is true for all possible values of under root x. So under root x has to be real in the sense we must get x in this interval. Now you might have understood finding the domain, natural domain of these functions. Now let us try and plot these functions also in graph. So let me erase off these things. My f of x in this case also is the same. Now we are going to change only the g value. So my g of x is what? It is 1 plus x, right? So now we have plotted both the functions. Here you may very well see the domain of these two functions. Now what did we do? We have done, we have inputted g to f. So this is what we got, and you may very well see the graph of this composition, and we have done this g of f of x also. That also we can very well see, right? So this is what actually here, while calculating these things, we have not found the range. That range we may see from the graph. Okay, so the range is going to be what, from 0 to infinity for the first case. Okay, whereas for the second case it is going to be 1 to infinity. Let us write that too. Okay, from current slide, let me give. Here what is happening, the range of f composite g is what, it is 0 to infinity, and similarly the range of g composite f is 1 to infinity. Okay, thank you.